discuss the portable and direct push NMR tools. So the probe, as shown here in the center, the yellow probe here, the construction of the probe and the measurements it makes, it's the same as in the previous section. Um, but the difference here is that the probe is smaller and the whole package is more portable. And some variations of this dart, so this is called the dart probe in that's our product. Uh, they can integrate with direct push drill rigs. So uh, here's an example of a log from a direct push dart measurement. We can see at 20 meters and at 44 meters, um, there are some uh, well-sorted sands. We have a high hydraulic conductivity zone between 30 and 40 meters. And then in the near surface, there are clays. And we can see that the clays are shown by the short T2 distribution, low hydraulic conductivity. The well-sorted sands have a long T2 time. And then the high hydraulic conductivity zone here has some of the longest T2 times. Um, Also, there's another such zone here that's not pointed out, but of course between 47 and 53 meters, there's another zone of relatively long T2 decay times and high mobile water content, high hydraulic conductivity. So this direct push or this Dart system is highly portable. It can integrate with direct push rigs, and that, of course, allows it to be deployed without having to drill and case a permanent borehole. You can get an NMR log in a location in a day and abandon the boring afterwards. So this is just an illustration of the deployment of the direct push system. So uh, direct the direct push drill rods are driven into the ground, and then the probe is deployed through the rods after they've reached their total depth, and then the uh, rods are retracted, allowing the probe to hang from the bottom of the drill string. And then NMR measurements are made as the probe is drawn to the surface. So um, NMR, I mentioned that it can measure through PVC casing. It can log in open boreholes in PVC casing, but it cannot log through metal. So that's why in this application, this direct push integration, the probe is suspended from the bottom of the rod string because the probe can't operate um, through the metal rods. So next, I'll briefly mention the surface NMR method. Um, this uses, instead of permanent magnets that are in the probe, the B naught magnetic field is from Earth's magnetic field. And the method operates by laying out large loops on the surface, and then a similar excitation pulse as with borehole NMR is run through these surface coils, and then the same physical response in the hydrogen nuclei is generated and measured on the coil. So the advantage of this method is that there's no drilling required. It's completely non-invasive, and it provides essentially the same results, the same data products as the borehole NMR, with a few variations. There are some limitations to this method. It's very sensitive to electromagnetic interference, so you cannot be too close to power lines or infrastructure. It works best in rural locations. Um, and if there is highly conductive ground, that will limit your depth of investigation. If there's high magnetic susceptibility, that can cause problems with interpretation. And if the water in the subsurface is in very small clay-bound pores, and then it can be difficult to detect those using this method. So I won't go into too much detail in the processing of surface NMR data. Um, it's a bit different than the processing of logging data. Logging data is simpler in that the depth information just comes from the location of the probe, whereas the depth information with the surface NMR, uh, you have to invert the data, do a geophysical inversion to project the data to depth. So, as with any such inversion, the resolution decreases as you go deeper into the model space, um, and uh, the results of a typical surface NMR survey or surface NMR sounding are shown on the right here. This decay time distribution, this is equivalent or similar to the T2 distribution that we saw with the borehole NMR. We have our log of water content. You'll note there's no clay-bound water in this depiction because that's um, not really possible to detect, or it's more difficult to detect with the surface NMR. And then we have our estimated hydraulic conductivity. So it's very similar data to the borehole logging NMR, but with a different vertical resolution because of the fact that it's operating from the surface and you're doing an inversion to get the depth information. So now here we'll go into some examples, some case studies, some applications of the technology. So there's a lot of interest and growing interest in using NMR for mine tailings. This is the illustration shown here is one of the early tests of our direct push dart NMR system that we did in Arizona with Contech. Um, this project, actually, we did a series of direct push logs using this CPT truck, and those were adjacent to a uh, borehole. You can see the PVC casing here next to the CPT truck. This was a borehole that was drilled and 3-inch casing was installed, and this was logged with a traditional Javelin logging probe. And then that data was correlated or compared with the direct push result. And we got good agreement between the two. So in this example, we can see we're inferring that there's a water table at about 45 feet. Below that, you can see the overall water content, and the mobile water content is slightly higher. Um, that's our clue that that's where the water table is located. And one of the some of the interest in using NMR and mine tailings is to estimate void ratio for analysis of mine tailing stability. Uh, so here, this also mentions that the pore size distribution is derived from the NMR measurements. And in this example here, this is overall fairly low mobile water content was detected in this log here. We've also done logging in um, earthen dams, tailings impoundment dams. This is a tailings impoundment dam in Montana in the United States. So the objective with this study was that the mine operator was um, seeking to increase the height of their tailings dam, their tailings impoundment dam, and um, they were wanting to get more information about the materials and the condition of the dam. Limited records existed about the early years of construction, and the NMR was logged in a series of boreholes along with existing that data was combined with information from an existing piezometer network, and the objective was to look for evidence of perched water. We also have there's a NMR logging system that's being used in Yanacocha gold mine in Peru that has been operational since 2023. Um, I'm not Vistaclare is not involved in any of the analysis of that data, and we can't really speak to how it's being used. Some of you on the call may be more familiar with the work that's being done at Yanacocha than I am. So I don't not able to show any data or any results here, but just wanted to mention that um, that work is being done. Uh, NMR is also used in um, brine mining, solution mining, lithium production. So SQM in Chile has been using Javelin systems for many years now in multiple applications. Um, they use it for optimizing well construction and most importantly for estimating resource size because the NMR provides effective porosity and they combine that with their estimates of mineral concentration and that provides an estimate of resource size. So NMR, I mentioned earlier, it is used in the environmental remediation industry. Um, for the purposes of high resolution site characterization and development of conceptual site models. This is an example from Nevada in the United States. Um, there's a uh, there was a factory that exploded in the 1980s and released a lot of contamination into some of the local waterways. So there's a large environmental cleanup effort and in uh, yeah, around 2018, 2019, a lot of the wells in this area were logged with uh, NMR logging tools, and that information about the hydrogeology was used to inform um, the groundwater flow model for that was used for mapping contaminant flow and understanding groundwater migration in the contaminated zone. Here's another example of high resolution site characterization. This is a direct push NMR log. Here you can see there's a fairly large change in the aquifer properties just below 10 meters. Above 10 meters, we have uh, very long signals, high mobile water content, high hydraulic conductivity. And then below 10 meters, um, the overall water content is similar, but the pore sizes are completely different. We have short T2 decay times and uh, That's therefore indicative of water in very small pores, very low hydraulic conductivity. And the other feature of this study um, was that some HPT profiling was done in this location as well. And HPT, this hydraulic profiling tool, it provides a physical measurement of hydraulic conductivity. So the strength of that compared to the NMR, NMR is only estimating hydraulic conductivity. The HPT tool is physically measuring it. So that is uh, preferable in some ways, but it has a limitation in that there's an upper limit to what it can detect because of the limitations of how fast it can inject water, how much pressure it can generate. So it's limited to estimating an upper limit of about 30 meters a day that can be measured with the hydraulic profiling tool. Whereas NMR, um, it can estimate much higher hydraulic conductivities. So here we're estimating um, almost, well, depending on which method you use, 100 to potentially up to 1,000 meters per day. These different curves here, SDR and SOE, are different uh, methods for estimating hydraulic conductivity that make different assumptions. Um, I mentioned these relationships are kind of semi-analytical, semi-empirical, and they make different assumptions about how the NMR relates to um, hydraulic conductivity. So some may be more or less appropriate in different situations. These multiple methods exist in the literature, so we include them both in our software. Um, Next, we have a geotechnical example. This is a large infrastructure project from the United Kingdom. Um, this was actually done in a river on a jack-up barge, and the objective was to characterize the sediments for future tunnel construction and allow them to plan their dewatering. Excuse me. Um, and this provided the information that they needed for their work. Um, for time, I'm probably going to skip some of these examples of surface NMR. Um, this is an example of a DART survey, and here you can see that the one of the advantages of the DART is because of its size, because of its portability, you can access remote locations, as shown here. We hiked the system into these locations, and then we were also able to return over a period of a year and a half and make measurements in different locations in this drainage basin in different conditions. So in at the BC top location, there was not a significant change through the seasons. At the Willow location, the lowermost location, there there was a significant change between the seasons. So more mobile water content in early summer than in late fall. So this kind of spatial and temporal information was made possible by um, having this portable system that allowed um, easy repeat measurements and easy access to these locations. So here are some examples of NMR being used in kind of novel ways in remediation, in environmental remediation. So um, biofilms or biofouling can be used to um, block pores and impede um, water flow, and that can be measured by NMR because um, the pores are smaller, the T2 distribution is shorter, and that was exactly what was detected in this um, project. You can see as time goes um, increases here, the T2 time decreases, and then it reaches a baseline after about 5 days, and then a solution to kill the biofilm was injected at day 14, and the T2 time then returned to its um, original state. So this is a similar example with precipitation of a material that's again intended to block groundwater flow. So this is at a former uranium mill site in Utah, and the um, uranium left over from the mill operations is migrating into a local river. So this was an experiment um, undertaken by the Department of Energy to, um, or yeah, undertaken by one of our national labs to um, precipitate this hydroxyapatite material that would impede groundwater flow. So here you can see in these red boxes, the blue curves are before the injection of the material that's going to precipitate and block the pores, and then after the injection, you can see there's a significant drop in the hydraulic conductivity. This is hydraulic conductivity is plotted here. Um, so significant decrease in permeability can measured with NMR as a result of these active remediation efforts. Um, so just a few more slides, and then I do want to leave some time for questions. This is a new tool that we are in the process of finalizing. Um, this combines CPT with NMR into a single tool. So your typical CPT measurements are done by the CPT cone, and then there's a non-metallic section of this probe that will make NMR measurements. So CPT measurements are done on the way down, and then the probe is withdrawn and NMR measurements are made on the way up. And again, all of your typical CPT and NMR data products can be obtained with a single tool in a single um, logging operation. Here's some examples of that tool in action with the NMR data on the left and the CPT on the right. Um, and here we're identifying some silts and clays um, and some interbedded sands in the mix there as well. Uh, I'll keep moving and try to finish up here. Here's another example of this tool in use. This is a fairly homogeneous log here. You do have more clay-bound material through the middle of the log, but then there are a few sections um, with some longer T2 times, some more mobile water content that are indicating some sands, and that can be picked out in the data here. So that is everything from us. We would welcome any questions from anyone. Thank you all for being here.
Ok, alguna consulta, y creo que hay consultas. Alonso, ¿te parece si filtras las consultas, por favor? Or I don't know, Alonso is not here. Eh,
Ya,
Dr. Warren,
no puedo ver, no puedo ver las consultas.
don't worry. Dr. Warren, I send you the question. Uh, it seems that surface NMR can be used to locate groundwater. What is the difference between surface NMR and electric tomography?
Um, so uh, the the biggest advantage of surface NMR for groundwater investigations is that the signal that you're getting is directly from groundwater. So it gives you unambiguous detection of groundwater. So with other geophysical methods, including resistivity, the physical measurement that you're making is usually not of direct interest in itself. Um, it- that's typically, well, yeah, that includes resistivity usually. Um, you're making an inference about the geology or the lithology or some parameter of interest based on that physical measurement. But with the NMR, because you're getting an unambiguous detection of groundwater, you're getting a direct, um, much more direct information about hydrogeologic properties. So it depends what the objective is, but if you're interested in groundwater, the NMR uh, is very powerful in that you're getting a direct measure of water content, the volumetric water content, and um, the pore size distribution and those hydrogeologic properties. Uh, okay, so I see a question about using Dart in a 63 millimeter um, PVC. Yes, so um, uh, the smallest, so the Dart system comes in two um, diameters. We have a 1.75 inch and 1.4 inch version of the Dart. Um, so the 1.75 inch 44 millimeter, um, yes, you would be able to deploy that in a 63 millimeter PVC casing. Um, if there are installed piezometers, um, you need to be careful there because there can be two effects. Um, any instrumentation that's installed for example, in the annular space of a well, if that has if the sensors are metal or there's copper wiring, that can impact the NMR tool negatively by introducing noise, or if there's sufficient quantities of metal, it can actually um, potentially damage the electronics in the probe. That's unlikely. A more likely effect is simply that there would be electromagnetic interference. But the other effect that you need to consider is that because there are permanent magnets in the probe, um, those can adversely affect the piezometer sensors. So it's best not to log with NMR in any instrumented wells.
Okay, thanks. Good morning. Thank you. So, do you have any question? Insist, no?
Oh, sorry, I only heard a part of that.
Okay, that's more. Thanks for your time, Dr. Warren. It was a wonderful presentation.
Very good. Um, well, yeah, thank you all for attending and thank you for the opportunity.
Gracias a todos por su tiempo. Muchas gracias también al doctor Warren. Ya no hay, ya no vemos más consultas. En todo caso, muchas gracias. Thanks a lot, doctor Warren. Eh, voy a parar la grabación un segundo.
Record.